Hello. Good afternoon. Well, uh, you'll find out how we're gonna do this. All right. Well, welcome to Project 3, Derivative as a Rate of Change. I'm Daniel Costa, student ID is 225-4144. Now, we're going to go over the definition of, I'm trying to remember really quick. Oh my God. We are learning about, what are we learning? Derivative as a rate of change. We're going to go over the problem we're going to do. From what I saw, it's just one. So we're going to do that today. And we're going to just two references. So what is a derivative as a rate of change? So according to Stuart J from 2015, the derivative as a rate of change refers to the concept that the derivative of a function represents how one quantity changes into relation to another. It measures the instantaneous rate of change from a function's value as its input changes. So in the real world, for example, applications like physics, the derivative of a position functions with respect to time gives the gravity which describes how position changes over time. Essentially, it provides the slope of a tangent line to curve at a given point. Also, just like reflecting how steep the curve is at that particular location. So we're going to go over right now the problem and the solution we are going to do. So keep in mind, some reason there's a little bit of a copy and not like a copy and paste error, but more like when I try to copy the numbers, it would just duplicate on its own. But I have my notes next to me, so I'll just read it how it is, and we'll move on from there. So when does the particle move forward, backward, speed up, or slow down? So it move forward at 0 is less than t, but t is less than 3, and 5 is less than t, but t is less than any 5 or 8. I don't know why. The particle moves forward when the velocity is positive, which is when the graph is above the horizontal axis. It's greater than 0. Now we move backwards. 3 is less than t, but t is less than 5. The particle moves backwards when the velocity is negative, which is when the graph is below the horizontal axis. So it is less than 0. We do speed up. 0 is less than t is less than 1 comma 3, but it's 1 comma 3 is less than t is less than 4, and 5 is less than t, and t is less than 6. The particle speeds up when the velocity is increasing, meaning the slope of the graph is positive. Now we slow down. 2 is less than t, and t is less than 3 comma 4, and 3 comma 4 is less than t, and t is less than 5, and 6 is less than t, and t is less than 8. So essentially the particle slows down when the velocity is decreasing, meaning the slope of the graph is negative. So as we continue, when is to the next part, when is the particle's acceleration positive, negative, or 0? So positive 0 is less than or equal to t, and t is less than 1 comma 4, and 1 comma 4 is less than t, and t is less than 6. So positive acceleration occurs when the slope of the velocity is positive, which essentially means the graph is sloping upward. So negative acceleration, 2 is less than t is less than 4 comma 6, and 4 comma 6 is less than t, and t is less than 8. So negative acceleration occurs when the slope of the velocity is negative. The graph is slowing down. And at 0 acceleration, 1 is less than t is less than or equal to 2 comma 6, and 2 comma 6 is less than or equal to t, and t is less than or equal to 8. The zero acceleration occurs when the slope of the velocity is 0. So which essentially means is the graph is flat or horizontal. Now if we go to part 3, which is when does the particle move at its greatest speed? Greatest speed is at t equals 4 and t equals 6, which you can't see for some reason. The greatest speed occurs when the particle velocity has the highest absolute value, in which corresponds with the farthest points of the zero of the graph. This occurs at t equals 4 and t equals 6, where the velocity is -5 and 5 respectively. So if we go to 4, when does a particle still stand for more than an instant? So it stands still at 8 is less than or equal to is t, and t is less than or equal to 10. The particle still stands still when the velocity is 0 for more than an instant, indicated by the flat horizontal line at v t equals 0 on the graph. This occurs in the interval a is less than or equal to t, and t is less than or equal to 10. And as we can see, the answers are right here. Thank you for listening to this presentation. I shall provide the link to the video at the end, and here's the resources I used. Good day.